So today we're going to talk about motion. Everything is always in motion. Doesn't matter what it is. If you see something just sitting still, it isn't moving. Right? That's science. Right? Two things we need to talk about are vectors and scalars. So a vector is something that has magnitude and direction. So I say I kick a soccer ball with 5 newtons of force east. That's a magnitude, which is my 5 newtons. And I kick it east, which is a direction. Now, if I just say I kick a ball with 5 newtons of force, that's called a scalar. So a vector has both magnitude and direction. A scalar just has magnitude. Some scalars are like temperature, mass, speed. Some vectors, the big vector we're going to talk about here is velocity. Velocity is speed and with direction. All right, speed. Speed is a scalar quantity. So the formula for speed is speed equals distance over time. It's a very simple formula. All right, I'm going to give you an example of it. So if I say I'm going a distance of 30 miles, right? And then I say I'm driving for 2 hours. What's my speed? Just divide the two and I get my speed equals 15 miles per hour. Right? That's how you find speed, just distance over time. Now, for another example, what if I say I'm going 60 miles per hour for a distance of 120 miles? How much time is that? So this is a weird way to solve it, but you have to get the t out from underneath there first. So you multiply both sides by the t to move it. So I get 60t equals 120. Then divide by 60, divide by 60. So my time is 2 hours, because this is miles, and this is miles per hour. Miles cancel out, and you have hours left. And there you go. Time, 2 hours. So that's how you do it different ways. You can find the speed, you can find the distance, you can find the time. If you want to find the distance for this one, so if I said I was going 60 miles an hour for 2 hours, how far did I go? So then I just multiply both sides by 2. And I get 120 miles equals your distance. So there's a bunch of ways to do it. Remember, this is a scalar quantity, so it only has magnitude. All right. Now we have velocity. All velocity is speed with direction because it's a vector. Speed was our scalar, just had a speed just had a magnitude, but this has speed with direction, or magnitude with direction. So instead of saying I just went 30 miles in 2 hours, I would say I went 30 miles east in 2 hours. So what's my velocity? It is 15 miles per hour east. That's really the only difference between speed and velocity. It's just giving you a direction with it. Basically, they become interchangeable with you as you go along. Now we have acceleration. Acceleration is the change in velocity of an object. So the formula for this, I might have spelled it wrong, I have no idea, is acceleration equals basically the change in velocity over your time, or you can say change of time. That can also be written as A equals your final velocity minus your initial velocity, or your starting velocity, whatever you want to say. Initial and starting is the same thing over your time. You always do what you end at first to subtract it. That'll show you if it's decelerating or accelerating. And we're going to do some examples here. So what if I say I'm going 50 miles per hour. 50 miles per hour and then I slow down to a stop in 10 seconds. What is my acceleration? All right, so this one's a little bit tricky to start with, but we'll start with it anyways. So we throw in our formula: acceleration equals a change of velocity, or I'm gonna write the second one. So our final velocity minus our initial velocity over time. So what's our acceleration? So what's my final? Where do I get to? So I'm slowing down to a stop. So I'm gonna end at 0 miles per hour. So that's 0 minus what I started at, 50, over my time of 10. So then I get, my acceleration is negative 5 meters per second squared. Acceleration is always measured in meters per second squared. All right, so there you go. You don't really, the negative just means it's decelerating is all it means. That's it. So you can have a negative acceleration, but that's just deceleration. So you can say this decelerates at 5 meters per second squared, or you can say the acceleration was negative 5 meters per second squared. It means the same exact thing. Now what if we change this around and said we started from a stop. So that would make our initial velocity 0 miles per hour. So we were stopped at a red light. And then we speed up to 50 miles per hour in, let's say, 2 seconds. Now this changes the entire thing. So my acceleration, I'll have to do 50 first because that's where I end at. You always do the ending first. Minus what I started at over 2 seconds. So your acceleration is 25 meters per second squared. Always meters per second squared. And there you go. That is acceleration and deceleration. It's really not that hard. It's just figuring out, the hard part is figuring out where you start at and where you end at with your velocity. All right? So there you go. As long as you get that. So basically if you see like I'm coming to a stop, right, you're decelerating. If you use your common sense, it's really not too difficult. All right, this is another section that's on the lesson. So it's basically graphing your velocity, acceleration, or graphing motion. So if I have high velocity, all right, those are just constant dots. All right, nothing's happening. It's moving at a constant rate of, let's say it's 25 miles per hour. So the difference between these would be 25, 25, 25. 25 miles per hour for Mark. If you want to think of it that way. So that's high velocity. Low velocity means you're going slower, so the dots will be closer. But still constant. Now when you talk about acceleration is not a constant rate. Right? Acceleration changes. It's more of an exponential, or it is an exponential. So high, or we'll just say acceleration for this. So acceleration, it'll look like low velocity at first because it is, but then the dots will start getting more spread out and more spread out. And there you go. That's acceleration. It's not constant. Decelerating is the exact opposite. I probably spelled that wrong. I'm a terrible speller if you haven't figured that out at this point. Spread out and then they get closer. Alright? That's deceleration, acceleration. So deceleration starts off fast, comes to a stop. So think this is a car. You see a red light, you hit the brakes, you slow down. Here, the red light turns green, you speed up and go. This is the in-between. You're always going that constant 45, or since we're in Georgia, you're probably going 80 into 35. And that would be this high velocity. All right, now the last thing it has in here It's basically just an overall look of a position time graph. You need to know more about it than this, but I'm not gonna go into it because it doesn't. So this is just a constant positive rate, right? It doesn't change, it's just a linear function. It just goes on and on forever. This is how you find your slope. This is positive acceleration. No, I'm not gonna write any more than that. And this is negative acceleration. What is another name for negative acceleration? I talked about before when I did the problem. It's also called decelerating. Call it whatever you want. Doesn't really matter, just as long as you know it's when you see negative acceleration, you decelerate. So this is what the graphs look like. Constant, positive, starts off slow, goes up fast. Negative is you're just slowing down to a stop. Acceleration is not constant rate. Exponential, linear. This has been Motion. Hope it helped. Good luck.